Welcome, class. If you're seeing this, that means unfortunately my little ones are not doing too well. So yeah, that cold that's going around. Anyways, so we're going to finish up with the indirect proof today. That we're just, as you see, focusing on one aspect, the contrapositive. All right. So as you see that right down there, that's what we're going to focus on. So this is it. All right. And just as a reminder, we do have a test coming in, so I hope you guys still know where your definitions, like definition of midpoint paper is. That'll be helpful. So let's get going. So we're going to have discussion. Class, we're going to practice tests as well tomorrow. So just as a reminder about that. All right. So the gist of the contrapositive. A contrapositive swaps hypothesis and conclusion and negates both. If not conclusion, then not hypothesis. It's basically what you're doing. So normally with a conditional statement, you see if something, that's our hypothesis, if P, then Q, then something else. We look for those flag words, okay? So a converse just flips them, and a contrapositive takes negative of both. All right? So why would we need this? For two positive integers, n and m. This is like a little bit more of a detailed example, but you'll see what we are dealing with here in a second. Okay? So, for two positive integers, n and m, if n m is strictly larger than 36, then either n or m is greater than 6, or both are greater than 6. So what are we saying here? It's always a good idea before you do any proofs, because you won't always have the strong guidelines. You always good idea to break it down. So what are we actually saying? All right. For two positive integers n and m, if n and m is bigger than 36, notice that the key factor is if. Our hypothesis is actually n and m is bigger than 36. These two positive integers is just giving us kind of guidelines or parameters. In other words, we cannot use negative numbers. That's all this part is saying. But what we're saying is if we have a number when we multiply it to get two numbers, when we multiply them together is larger than 36. This is our hypothesis. All right, so that's what we're saying is true. So the notice key here, the hypothesis that's saying is if n times m is 36, bigger than 36, and m are both positive integers, or basically solid numbers. That's what integers are. Solid numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5,633,000. Who knows? All right. Then either n or m is greater than 6, or both are greater than 6. So we're looking at the fact that we're looking at both cases. We either have one being greater than 6 or both are greater than 6. So let's just go ahead and, as always, it's a good idea to play around with these just to get a good feel of what's going on. Okay? Since 6 is key, and let's just look at the divisors of nearby numbers that are bigger than 36. 37? Well, that's easy. It's prime. 1 and 37. Notice 37 is larger than 6. So that clarifies for this. 1, n or m, is greater than 6, not both. 1 is, in this case, 37. Since 1, that's all. For a prime number, that's all we have. Let's look at 38. 38 has 1 and 38. Again, one number, 38, is bigger than 6. All right? Now, the other thing we have is 2 and 19. 19 is a prime. 2 is a prime. That's as far down as we can really mess with. But notice again, 19 is bigger than 6. So we can kind of see that this is going to be true. Seems true, as we said, seems true. But we have to prove this for every number. Notice that we just looked at 37 and 38. We can look at 39. We can look at 40, 41, 42, 43. 8 quadrillion, 632,936, etc. We can look at all those numbers, but we have to prove that this works for every single number. Just saying, oh, it works for 37, it works for all, does not work. Just saying, oh, look, it works for 38, so it works for all, does not work. You have to prove without a shadow of a doubt that it works for every single number beyond 36. All right. Since we can see that it is working, we're having a case of we have one number, and one number bigger than 36. Let's go ahead and look at how we would prove it. So prove two numbers, and then it's bigger than 36. That's what we're working at. This is why the indirect is definitely very useful. Look at the contrapositives of Q and P. So we're looking at what we have so far. We have NM is 36, and N or. Notice that we have ors right here, or both. Either this, or this, or this. What's the opposite of ors? Ands. So you might want to think about that. So let's just go ahead and continue on a little bit, okay? So it's just something to think about. So not and m times is strictly greater than 36. It means that we're at least as big as 36. So NMM is 36 or smaller. So less than or equal to 36. NM is less than or equal to 36. Now we have that or again. That means as long as one of those is true, it's okay. Just like right here. As long as one of these is true, it's okay. So now we switch that or out for an and. So that means N and M are smaller than 36. We're still dealing with two positive integers. That's only leaving us very, very few numbers to really concern ourselves with. But let's continue on, shall we? So we have a starting point for what to do at this point. So we have down here the transfer property for a hint, AB, BC, AC. We have that also on the handy little note sheet. So, time to prove. We have not Q, both are smaller than 6, not P, less than or equal to 36. So step 1, assume the not Q is true. That means we're just assuming this part right here is true. Smaller than 6, smaller than 6. Both are smaller than 6. Okay? So, N is less than 6 or equal to 6, and M is less than or equal to 6. So, show how these assumptions lead to not P, which is 36. Well, you can see how it's going to be pretty easy because as big as the number of these you can both get is 6. All right? But let's just go ahead and break it down. Notice that we're trying to get to NM less than or equal to 36 on one side. So M is less than or equal to 6. But we can, if we multiply both sides by N, this side and this side, we can get the NM, which is on the left-hand side. So as long as we get to this NM and we figure out how to get to this 36, we're good and golden. So let's multiply both sides by N. So now we have NM is less than or equal to 6M. All we did was multiply by 1, which in this case was that N. So we didn't change anything. It's like multiplying both sides by 5. If N happened to be 5, 6 times 5 would have been 30. M times whatever N is times 5 would have just been 5M. We still would have been okay. All right? So let's just go ahead and hold off on that for a second. Now let's look at the N6. Remember, we want to get basically to a 36 in this or. And we kind of have a good clue right here at 6N. So if we can get to 6N on this side, and basically a 36 on this side, we can use the translate property. A is equal to B is equal to C, and A implies C. We kind of have an A over here, and a B right here. So if we get the B right here, and a C over here, good to go. So we're going to multiply both sides by what? 6. So we're going to take that 6, spread it on out. 6 times N, 6 times 6. Let's go clean this up a bit. So we have 6N is less than 36. So this is where that transitive property can come into place. A is less than or equal to B, and B is less than or equal to C, then A is less than or equal to C. And that's exactly what we're trying to get up here. A is less than or equal to C. So we'll see step 3 on this next slide. So let's just go ahead and pause if you need to. Take a picture. Just hold off a little bit before we continue on. All right. So as you see, it breaking it down, trying to get a good understanding, does help. Okay. Step 3. Conclude that P implied is true. Proving a contrapositive proves conditional. Therefore, two positive integers nm, if n times m is bigger than 36, then either m is greater than 6, or you just restate the thing because you were able to show with this last slide what you were trying to prove. So basically, by getting to this point right here, you were showing that this is true because you were able to say, hey, we started out with an nm, and we were able to get this. So we started out with this and able to get over here just by mild multiplication, multiplying both sides by n on this side, and multiplying both sides by 6 on this side, so we can connect the two. So you could use the transitive property and go from there. All right. So today you will have a handout. It's from Pearson's front and back. Go ahead and get through it, and it shouldn't be too bad. So sorry I'm not there to help with that exactly. And just remember, Thursday is a practice test. So you will be able to use that note sheet on the practice test and the actual test with all those definitions. All right. So have a nice one.